All right, so now let's move on to lift chart. And lift chart is more precisely data mining measure. So this is not something that is used in classical statistics. So here we are not interested in predicting a particular value for y hat. As long as you're able to, for the future data set, you can correctly sort the data set in whatever order you want, ascending or descending order. The relative position of the observations is what you're interested in, not the exact prediction of each observation. So that is the goal. Sorting is the key. So it is not relevant if the goal is to predict the outcome of each new factor. So that's not if that's the goal, then lift chart is not going to work. Okay. So what we have now is the Toyota data set. Okay. We're going to come up with a model, and in that model, okay, if we want to see whether that model is used, so this one has all the predictor variables and the target variable price. We already have all that. Okay. Now you have a new data set coming in. So you have a bunch of cars that is coming to the market. And now we want to predict the price of these new cars. So these new cars have all the predictor variables, but it does not have price. It does not have the value of the market. So we want to take this model, apply it here, and we're not really interested in figuring out what would be the price of each car in this data set, but we want to sort it. If you don't want all of these, lousy cars, we want only the good ones, which will fetch good price. So the price that you're going to predict, you sort. Okay, now what you're going to predict? You don't have the y value, you don't have the price. All you have is y hat. You're going to apply this model to this data, and you can compute y hat. All right. Now you're going to sort this data set by y hat from largest to the smallest, hoping that that would be the exact order in which the actual price would be. So that's what we are interested in. We want now, how good is this model? Okay, the new data set, we don't have the price. So we cannot know how well it sorts the new data set. So what we're going to do is in the existing data set, we're going to have, like we've always done, trained data and validated data. Trained data, we fit the model, okay, and apply it to the validated data. In the validated data, we have y as well. So we sort this data by y hat, and then see how that sorts the y value. If the y value gets sorted very well, then the model is good. But if y is all over the place, you sort this data by y hat, largest to the smallest, the y value is just random, fluctuating everywhere. So that means the model is no good. Right? How well y hat, sorting y hat, how well it coincides with sorting of y. So that's what we are interested in doing. Okay. So let's do this in Excel first. Okay. Lift chart. So we have the model now. So we are not interested in training. We are only interested in validate set. So let's copy these two columns over. Okay, so let's put it somewhere here. Okay. So now what we need to do is sort the cases by y hat. Highlight. data sort. Now we want to sort by y hat, and we want to go largest to smallest. So it's sorting by column K. Now, of course, you're not going to be able to just look at the numbers and then see how well y is getting sorted. Okay, you're sorting the whole thing. Don't just sort this column. You want to sort both columns. Okay, this both J and K, but the sorting key is column K. Okay, so now we're going to use column Y, the Y values to set up. Okay, so it's going from largest to smallest. We're going to do a cumulative column of Y, and then we will compare it against average Y bar. Okay, so we have cumulative Y, and then do Y bar and cumulative Y bar. If you want Y bar, you can go and insert symbol, look for Y bar. That's somewhere. If you go to MS reference and set it. I think that's where you have Y bar somewhere there. You have to look through it. Oh, I don't want to waste time on that now. So Y bar, cumulative Y bar. So, cumulative Y. Okay, so there are a couple of ways in which you can do this. Say you want sum of J6 with J6, except that you make the first J6 absolute reference. $J6. So when you copy this formula, the first cell will always be J6. The second cell, the end of the range, will now change from J6 to J7, J8, J9, and so on. So every cell will be a sum starting from the top up to that point. So this is one way of doing it. Okay. This may be computationally not very efficient. So another way of doing it is the first one is just that, and then the second one is the previous sum plus the new value. Okay. Now if you do the plus and double click, it won't work. Why? Because the adjacent column is blank, so it's not going to work. So what I'm going to do is I'm going to copy and then go down all the way using this one, come back up and then go up. So that's the quickest way. So copy here and then move over to end down. So take all the way down, then move back to the column that we need to copy, press shift and then highlight. Alright. So this is one line that we're going to plot for the lift chart. Okay. And we're going to compare that against Y bar, cumulative Y bar. Yes.
Can you go to cell M6?
Which one?
Cell M7.
M6?
7.
That one?
Yes.
Okay. So that one is that plus that.
Okay.
So previous sum plus the new value.
All right.
Here. Okay. So we're going to plot this, and we'll need case number. So I'm going to insert column here. Okay. That's your case number and plot that. So highlight those case, that one. Okay. And then insert scatter plot. Okay. All right. So we have case number here as x-axis, the cumulative y in the y-axis. So we start out with 0, and then we keep increasing. So as we add more and more cars to our list in this descending order, most expensive car at the top, the least expensive car at the bottom. So you keep adding. So at the end, you're going to have the sum of the price of the total value in the data set. Okay. Now we're going to compare that against y bar. Y bar is our baseline. Okay. If our prediction is not y hat, but it is going to be y bar, you start this by y bar, it's going to start randomly. So you start with y bar. So y bar. So average of that car. Okay. So that's the average, and we can set up a column of averages. Now that's the average car for the first car. Okay. And then we want a column of all averages. So if you say equal to C6, the same value will be displayed in O6, in 07. Now if you copy, so you get the same y bar value all the way.
Huh.
So we do the same like what we did here to y bar. So we start with y bar and then accumulate y bar.
I don't get the same Y bar.
Okay. All right. Now let's add the baseline cumulative y bar to the stock. So select it, go to design, select data. So we have cumulative y already there. Now we want to add, series name is cumulative y bar. The x values are same as that. And then the y values are cumulative y bar. Okay. This is case number 1 through 575, and this is the cumulative y bar. Of course, since y bar is all the same, okay, this is going to be a straight line. Okay. Okay. So now we do a legend. Okay. Okay, so now legend appears on the side. Now you can place the legend in several different places. I put it at the bottom. Okay. And we don't need to go beyond 600. So right click format axis, and here maximum we change that to 600. Okay. And then short title. So that one, let's put axis titles. X-axis will be cases in ascending or right. I'm sorry, descending. Then this will be cumulative price of cost. Now the lift chart, both lines will start from 0, and it will end at total number of rows in the x-axis, but at the end, they both will add up to the same total. So total of all jobs, the prices, and then the total number of observations. So the starting and the ending point for both lines will be the same. Now, if you have a lousy predictor, doesn't do a whole lot of good, then you're going to have this blue line closer to the orange line. It's not much better than the average. It's not doing it very well. We're not getting good value from it. On the other hand, if there is the gap is more, which means that it rises up. Of course, after some point, you're going to flatten, and then it will reach the same point as the orange later on. So the farther out the blue line is compared to the baseline orange, the better the model is. So that's what you should see in this chart. And